average or half time average, and then the other one is RMS, and then the other one is peak. Right, so these are the four kinds of parameters that are given, right? Any current, voltage, anything, right?
Yes.
So whenever the supply is given, so it is always, this value is always what? Among four, what is this value?
The volt RMS value.
Yeah. So always it is the RMS value, which is given,
Yeah.
right? But let's say if they give in this form, so let's say they give in 30 sine omega t plus, let's say 5. So this value is what?
V naught.
Yeah, so this is peak value, right?
Yeah.
Yeah, so if they give this kind of value, then it is RMS. If they give this kind of value, then we have a peak value, right?
Peak value.
So this is the thing that we have to first identify. But in most of the cases, they will give this peak value, this RMS value, right?
Mm.
Okay, so if yeah, this is clear, then now, right, that RMS value is given, VRMS is given. VRMS is 230 volt. Now we have to find out RMS current in the capacitor, right? In the
Yes.
capacitor, we have to find the current. So we know that in resistor, what is the voltage? Voltage current relation is this.
Yeah, VIR.
Yeah, but in capacitor, there is no resistance, right?
Mm.
So then we need to calculate the, this thing is the capacitor, this thing is the resistance in case of capacitors. And this is what we call, this is what,
Capacitative reactance.
yeah, so this is a reactance, right? Capacitive reactance. And this is how much? 1 by
1
omega
by
c,
omega c.
right? Good. So this is the value that we need to calculate, and voltage is given. So VRMS would be IRMS and then XC. So IRMS would be VRMS divided by XC. So we have to calculate, VRMS is given, we have to calculate XC. For XC, uh, angular frequency is given, omega is given. Omega is 3 radian per second. And now we have to, capacitance is also given. So C is given, which is 100 picofarad. Pico is 10 to the power minus 12, right? Okay, so then we can calculate, right? Then we can calculate what is yeah, so then we can calculate what is the IRMS, right? Or first, let us calculate this XC, which is 1 by omega C, which is 1 by 100 into 10 to the power minus 12. And then omega is 300. So this is how much? This is 1 by 3 and 10 to the power 4. So that this is 10 to the power minus 8. So it goes upstairs. This becomes 10 to the power 8. So 10 in by 3 into 10 to the power 7. So this is 3.33 into 10 to the power 7, right? Now we have to, so we know that is the conduction current equal to displacement current. So this is equal to, so we know that the conduction current is always equal to the displacement current, right? Magnitude is all.
Yes.
So these are equal, right? So let's, yeah, so this is A part. B part is, yeah, conduction current is equal to displacement current. Now we have to find out, determine the amplitude at of B at a distance 3 centimeter from axis between the plates, right? So we have to find out the magnetic field, right? We have to find out the magnetic field, and
Yes.
current we know, right?
Mm.
So we know that magnetic field of this circular thing, what is this value? For this disk, what is the magnetic field?
Nu naught by 2 pi into uh, I by R square, something like that.
Yeah, so mu naught, and then I, and then d by 2 pi r, something like
Mm.
that. So this is the magnetic field of the disk at some distance, right? At some distance. So we know that this I value, this I value for peak value, right? We want to calculate B naught amplitude, right?
Mm.
Something, and then sine some omega t. But we want to calculate this B naught. So B naught would be related with I naught, peak value. So this is I naught, right?
Yes.
So we have to calculate I naught. So what would be I naught? First, let us calculate I naught. We know that, yeah, so this is B naught would be mu naught, I naught, and B divided by 2 pi r square, right? So this is I naught is, this is a peak one, right? So we know that how this peak is related with RMS. So I RMS is I naught by 2, right?
Yes.
So I naught would be root 2 I RMS, right? And IRMS we have calculated, that is, oh, we didn't calculate. So this only XC we calculated.
Yeah, I
Okay.
was confused.
Yeah, yeah, yeah. So let us find that value first. Yeah, so IRMS is V was how much? 230 divided by, let me write 3.33 into 10 to the power 7. Right, so this value, this is 230 into 10 to the power minus 7 divided by 3.3. So how much this value? 23 divided by 3.3 into 10 to the power minus 6. So this is, let me divide this value. This is 23 divided by 3.3. 6.9. So this is 6.96 into 10 to the power minus 7 ampere. Yeah. So this would be root 2 into 6.96 into 10 to the power minus 7. This is into 1.41. So this is 9.85 into 10 to the power. So we know this value. Now we can put all the other values. So mu naught is how much? 4 pi into 10 to the power minus 7, and then I naught is 9.85 into 10 to the power minus 7. D is what is the distance we are calculating? 3 centimeter. So 3 into 10 to the power minus 2, and then 2 pi into r square. So r square, what was the radius or this thing? 6 centimeter. So 6 into 10 to the power minus 2 and 6 into 10 to the power minus 2. So 2 pi and then this is 2 and 10 to the power minus 2, 3. These are 6. Okay, so 9.85 by 12. And then this goes upstairs. So 14 and then plus 2. So minus 12. Right. And then we have 9.85 divided by 12. So 0.82 into 10 to the power minus 12, which is 8.2 into 10 to the power minus 11 Tesla. So this is the peak. Clear?
Yes, sir.
Okay, please note this one down. Then we continue the electromagnetic wave part.
I just need to note the last part.
Oh, the last part only. Okay, so please note that one.
So can you scroll down?
Yeah.
Done, sir.
Done. Okay, so now let us get back to the this one, right? Yeah, so we were doing this question. Yeah. So yeah, let us start this question again, right? Right. So this thing is given, electric field form is given, right? And this is some, if we compare with the general form, so this is E naught, and cos, and kx or ky. In this case, this is ky plus omega t. And right.
Yes.
So propagation,
So we did this part.
yeah, we are revising that part, right? So propagation
Okay.
is minus y, right?
Yeah.
Electric field is x direction, right? These are the two things that we know. And also, what is the, so E naught is 3.1 Newton per Coulomb, right? And then what is this thing? So K is 1.8 radian per meter, what 2 pi by lambda, yeah. And then this is omega is 5.4 into 10 to the power 8 radian per second. So these values we know. So from this thing, we calculate what is lambda. And then from this thing, we calculate omega is 2 pi nu or 2 pi by t. So this is how much? Nu is 2 pi or omega by 2 pi, right? So these are the things. What is the frequency? Now, what is the amplitude of the magnetic field part of the wave? So amplitude of the magnetic field. This is the amplitude, right? So we know
Mm.
that. What is the relation? So C is E naught by B naught, right? So this C would be, or B naught would be E naught by C. So this is E naught is how much? 3.1 divided by 3 into 10 to the power 8. So roughly we can write, or this is what? 1 point, how much? This is 0 and 3 into 10 to the power minus 8, right? So this is B naught, right?
Yes.
Now we were doing the last part, that write an expression of the magnetic field part of the wave. So we know that B would be B naught cos ky plus omega t, right? But the
Mm.
important part is that we need the direction, right? We need the direction. So we have to use this thing that E cross B, this would be n hat.
Is that-
Yes?
No, no. I was just thinking.
Yeah, so this is the relation that we know for propagation,
Mm.
right?
Yeah.
So E hat is I hat, right?
Mm.
Cross, let's say this is X hat, not X hat, but what do I write this thing? Let's say P hat, M hat, whatever, let's say P hat. And then N hat, we know that is minus of J hat, right?
Mm.
So what do you multiply? What do you cross product in I hat so that you get minus J?
Negative K?
So IJ is, so K cross I
Mm.
is, K cross I is J, right?
Yes.
So I cross K is what?
Negative J.
So this P hat would be K hat. right?
Okay.
So how? Because we know that I cross k hat is minus j hat. So p hat equals to k. Clear?
Okay, sir.
So this is a k hat, and now b naught we value name we know, which is 1.03 into 10 to the power minus 8, and cos, and the k value was given 1.8 y plus 5.4 into 10 to the power 8 t. So this is magnetic. Is it clear?
Yes, sir.
Okay, please note it down.
Done, sir.
Okay, so now let us do a set of questions. And are you revising all these things? Keep revising, otherwise you will forget.
Yes, sir. I revised this chapter.
Good, good. Okay, and yeah, first four chapters as well, right? So those are really important. Okay, so the second question is that in a plain electromagnetic wave, the electric field oscillates sinusoidally at a frequency of, so frequency is given, right? Frequency is given 2 into 10 to the power 10 hertz. And amplitude is also given, right? So amplitude E naught is given. is
So what
for
do we mean by amplitude?
amplitude. Okay, so let's say that whenever you have a wave, right?
Hmm.
So amplitude means that how high or what is the maximum value of this thing. Right? This is the amplitude, and this is the wave,
Okay.
right? So amplitude means that, let's say, if you plot the graph of, let's say, if you have y equals to 3 sine theta, right? Or
Hmm.
3 sine x. So let's say if your y is 2 sine theta, if your y is only sine theta, right? So then
Hmm.
what is happening is that if you calculate, so sine, what is let's say this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. So when I will do the AC part, I will talk about all these things in detail, right? So,
Hmm.
so if I plot the sine curves, let's say I plot this one. So sine 0 is 0, sine 90 is 1, right? Let us also draw what is. So let me draw. Okay, this would be, yeah. So this is 1, this is 2, this is 3, this is minus 1, minus 2, minus 3. Now let's plot this one first. So sine 0 is 0, right? And sine
Hmm.
90 is 1. So at this point, it will go as this, right? Sine 180 is 0 again, so it will go this. And then 3 pi by 2 is minus 1, so it will come here. And then 2 pi is 0. So this is the graph, right?
Yes.
So you see that this is the amplitude. Amplitude is 1, right?
Okay.
Now, if I plot the second one, let me plot the second one. So this 2 sine theta. So sine 0 is again 0, and sine 90. Sine 90 is 1, so 2 into 1, this would be 2. So it will go here, right? So it will go here. And then again at pi, it will become 0. And again at 3 pi by 2, it will become minus 2. And then this thing. Similarly, if I plot this one, so this will go like this, and then again 0, and then minus 3, and this thing. Oh, this is in here, right? So you see that whatever the coefficient is this thing, this will increase the maximum value. This will increase this height of or the crest or trough of the wave, right? So
Yes.
this part is what we call the amplitude. So if you have something like V equals to V naught sine omega t, right? So this part is what?
Amplitude.
Amplitude or peak, right?
Peak value. Yeah.
Yeah, so amplitude. Amplitude is peak value. You see, this is the
Okay.
peak, right? And in our case, we have something like this: E naught sine kx minus omega t, right? So this part would be amplitude,
Okay.
right? So yeah, is this part clear to you?
Yes, sir.
Okay, now let me erase this thing and let us go back to. Okay, so this is 48 volt per meter. Right. Now, what we need to calculate? We need to calculate the electric field oscillates sinusoidally at and amplitude. What is the wavelength of the wave? Right. We have to
Hmm.
calculate lambda. Right. And E naught is given. Right. So how can we calculate the wavelength? And frequency is given, right? So frequency is related with, let's say we know that C is lambda by T, right?
Hmm.
So we can write C as lambda nu, right? So we can calculate lambda as C by nu, right? So these two values we know.
Okay.
So C is 3 into 10 to the power 8 and nu is how much? 2 into 10 to the power 10. So this is 1.5 and then this is 10 to the power minus 2 meter, right? So this is the value of the wavelength. And what is the amplitude of the oscillating magnetic field? So what do we need to calculate? V naught, right? This is the thing that we need to calculate, right?
Yes, sir.
So we know that this E naught by B naught equals to C. So B naught would be E naught by C. So E naught is given 48 divided by 3 into 10 to the power 8. So how much this thing is 3 ones are and 16. So 16 into 10 to the power minus 8. So 1.6 into 10 to the power minus 7 Tesla. So this is the thing, right?
Yes, sir.
Okay, now we need to so show that average energy density of electric field equals the average energy density of magnetic field, right? So we have to show that average energy density. Do you remember what is average energy density of electric field?
No.
So this is half epsilon naught E square, right? In electric field, we
Okay.
used yeah, and average energy density of magnetic field. This is what? This is B square by 2 mu naught, right? These are the two
Hmm.
things that. So now we have to prove. We have to prove that UE equals to UB. This is the thing that we have to prove, right?
Hmm.
So we know that this E and B, they are related in electromagnetic, right?
Hmm.
And also, so let us write this UE, which is half epsilon naught E square. So we have to write in terms of magnetic field. So epsilon naught, we know that C is 1 by or This is mu naught epsilon naught. This we know, right?
Yes, sir.
So c square would be 1 by mu naught epsilon naught, right? This would be c square. So we can write epsilon naught. So let's take epsilon naught here. So this would be mu naught and c square. Clear?
Mm.
So let us write half epsilon naught is 1 by mu naught c square and then e square. So what is e by c square? We can write mu naught e by c square. Right. What is e by c? E by c is b. So
Mm.
this e square by 2 mu naught. And this thing is what? This is your energy density of magnetic field. So they are equal in electromagnetic wave, right?
Okay.
So now please note it down. Please note this thing down. Do you have any doubt in this one?
No, sir.
Okay, then please note it down. Yeah, so whenever we write this thing, this is always RMS. And this is RMS, 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 RMS. This is it. So I didn't write because generally whenever we write this thing, so it is understood that it is RMS value.
Okay, sir. Done, sir.
Done. Okay, now
Mm.
let's do the next question. Okay, so before we do all these questions, right? So let me write, yeah, so the energy intensity, right? So intensity, or it is also called flux, energy flux. This is what? This is power by area, right? And what is power? So power is energy upon time, right? Energy upon time, rate of doing work. So work is energy. So energy by time, and that is area. So this flux or intensity is energy per unit area and per unit time. Yeah, so this is the thing. And in case of electromagnetic waves or photons, in this energy is related as PC. So momentum into velocity, right? So this is energy is, let me write, energy equals to momentum into speed of light. So this is PC. These are the things that we have to remember. And yeah, please note down this thing. So rest of the question are using these things.
Okay, sir. Done, sir.
Done. Okay, now let us do these rest of the questions, right? And these are very important questions. Okay, so Mariam has this exam, but Mariam is okay. So about 5% of 100-watt light bulb is converted to visible radiation, right? So yeah, whatever power is generating in the bulb, and then the radiation is convert 5% of that power is converted, right? So let's say that then what is the power of the visible radiation? So power of visible radiation, that would be how much? 5% of this power, right? 5% of light bulb. So this is 5 into 100, right? So 5% into, and then this is 100. So this is 5, right?
Yes, sir.
Now we know this power, and now we have to calculate what is the, so at a distance 1 meter from the bulb. So let us calculate, right? So this is intensity we have to calculate, right? Intensity is power by area, right? So power we have calculated, that is 5 divided by area 1 meter. So this is 1 meter, and then we have to calculate. So for 1 meter radius, right, what would be this area? So this is pi r square, right? So this is how much? 5 divided by pi and then 1 square. So this is pi by pi, right? And then watt per meter square. So this is the intensity or flux, right? Second part is what do we have for at a distance 10 meters. So for 10-meter intensity would be, this is how much power is 5 divided by pi into 10 square. So this is 5 into, this is pi into 10 square. I can write it as 10 to the power minus 2. So this is the answer. Clear?
Yes, sir.
Then, yeah, please note it down. Oh, one mistake I have made. With the, yeah. So this is not pi r square. This is, so we are, from this point, we have this sphere, not this circle, right?
Okay.
So this bulb is generating the power in whole of the area. It is going like this, right? This is how the bulb is radiating in the whole site. So this is a sphere. And what is the area of the sphere? So that is 4 pi r square. So this is 4 pi. Yeah, so please correct that. Yeah, please correct this.
Okay, sir. Done, sir.
Done. Okay, so now let us do this question, and then in the next class, yeah, so this chapter is over, right? And there is this electromagnetic spectrum, so that you have to remember, right? You have to remember
Okay.
all those. So from 400 to 600 or 700, there is this visible range, and then there is radio wave, and then yeah. So the smallest is gamma rays, and then the biggest is the radio waves. So all these spectrum that you have to remember. Okay, so the fourth question is light with an energy flux of 18 watts per centimeter square. So flux is given, right? Which is the
Hmm.
intensity that is given 18 watts per centimeter square. So this would be 18 and then centimeter into 10 to the power 2, 10 to the power 2 watts per meter square, right? Because let me write it in this way. So this is watts and centimeter into centimeter, right? So this is 18 watts and 10 to the power minus 2 meter and 10 to the power minus 2. So this would be how much? 18 watts and into 10 to the power 2, 10 to the power 2 meter. Okay, so 18 into 10 to the power 2, 10 to the power 2 watts per meter square, right? So we have to change in SI units. Also, falls on a non-reflecting surface at normal incidence if the surface has an area. So area is also given. Area is 20 centimeter square. So 20 centimeter into centimeter, which is 20 into 10 to the power minus 2, 10 to the power minus 2 meters square. And time is also given. We have to calculate force. Okay, so we have to calculate, and time is given. So time is 30 minutes. Why they don't use the SI units? So 30 by 30 into 60 seconds, right? So these are the things that we know, and we know that these are the things which are related to energy. Energy is related to momentum, and momentum is related to force. So we have to think in three steps. First, we calculate energy. From energy, we calculate momentum. From momentum, we calculate force. Clear?
Hmm.
So first, let us calculate the energy. So we know that intensity is power, or let me write. Yeah, so area is given, time is given. So intensity is energy per unit area per unit time, right? So this is energy is I into A into T, right? This goes over here. So energy is intensity into area into time. So intensity is given 18 into 10 to the power 2, 10 to the power 2. Area we have calculated. This is 10 to the power 2, 10 to the power minus 2. And then this 30 into 60. So this one cancels, and anything canceling, so nothing. So this is 36, 360, and 80. Oh, so why they give? So this would be how much? 36 into 18 is how much? 36 into 18, that is 648.00. So this is 6.48 into 10 to the power 4 joules. So energy we have calculated. Now we know that this energy is equal to momentum into speed of light. So we can calculate momentum as E by C. Right? So what is this value? So this is 6.48 into 10 to the power 4 divided by 3 into 10 to the power 8. So this is 2.1 and then 6, and then this is 2.16 into 10 to the power minus 4 meter per second. So momentum we have calculated, right? Now we can calculate what? We can calculate force. So force is what? Momentum by time. So this is 2.16 and then 10 to the power minus 4 divided by time was into 60. So this is 2.16 into 10 to the power minus 4 divided by 18 into 10 to the power 2. So this is how much? 2.16 divided by 18 is 0.12 into 10 to the power minus 6. So we can write it as 1.2 into 10 to the power minus 7 Newton. That is the force. Clear?
Yes,
So
sir.
this is, first we calculate energy. From energy we
Mm,
calculate momentum. From momentum we calculate force. Yeah, this one is a very, very, very important question. So please note this one down.
okay, sir.
First note down the question and then the answer.